Welcome to Maths with EJD. Still on the subject of trigonometry, in this video, I'll be talking about submultiple angles. Previously, we had talked about sum and difference formulas. We've talked about multiple angles, right? Talking about double and triple. Now let's talk about sub-multiple angles. And of course, as we've always done, we go sine, cos, tan, and then we look at the things we can do around these things. So let's start. So how do you deal with sine A, for instance? If you ever have a need to expand sine A, normally when you see this, right, you can easily it can look very lost because you probably don't know what else to do with this. Well, for your information, right, we know that A is the same thing as half A plus half A, or that's A over 2 plus A over 2. Okay. So now that you've broken it down this way, so you can basically apply the same thing you've always done for sine A plus B. So in this case, this is sine A over 2 cos A over 2 plus cos A over 2 sine A over 2. So pretty much it's the same thing. So you can have 2 sine A over 2 cos A over 2. And that's what you have there. So it means the sine A is 2 sine A over 2 cos A over 2. Talking about multiple angles. Okay, so we can go ahead and talk about we can go ahead and talk about cos A. So cos A, of course, is the same thing as cos. Of course, I can say A over 2, or I can say half A. A over 2 and half A is exactly the same. So let me just use half A in this case. So here, when you have cos A plus B, it's actually going to be something like cos half A sine. Okay, no. Cos half A cos half A minus sine half A sine half A, right? So that now you have cos squared half A minus sine squared half A. Well, since the focus is on cos, right? We can always want to make everything to come out in terms of cos. So in that case, cos squared half A can now be, sine squared half A plus cos squared half A is 1. So that means that sine squared half A is the same thing as 1 minus cos squared half A. We did something like this under multiple angles, double and triple angles. So here we have cos squared half A minus 1 plus cos squared half A. So this and this are exactly the same. So we can add them together. So we have 2 cos squared half A minus 1. And that is exactly what cos A is. Okay. All right. So we've done sine and cos. And we know that tan can be sine over cos. But of course, we've had previous experience with tan. So we can actually tackle this separately. So we have tan A now. Tan A is the same thing as tan half A. I think I like half A plus half A. Of course, it's the same as A over 2, like I said already. So, and like you already know, this is the same thing as tan half A plus tan half A all over 1 minus tan half A tan half A. Okay, we follow all the process, and then this is the same thing as 2 tan half A divided by 1 minus tan squared half A. So this is exactly what you get when you break down tan A. So tan A is 2 tan half A divided by 1 minus tan squared half A. All right, so pretty much we have come to the end of submultiple angles, but then there's a twist to it which I like us to examine. So let's change our marker colors. Let me go purple here and then here. Say okay, here let's go black. Okay. All right. So now we've established all these things for sine A, cos A, and tan A. But then look at a twist to it. We can actually do a kind of transformation to this. Okay. So let's talk about transformation, transformation of submultiple angles, of submultiple angles. Let's say a transformation, because you can have all kinds of transformation. So a transformation of submultiple angles. So let's look at that. So how does that go? You already know from what we just did that tan A is 2 tan half A over 1 minus tan squared half A. That means that if we are taking it to be tan X, right? You know, tan X will simply be 2 tan half X divided by 1 minus tan squared half X. We know that. Now, let's do a transformation. What if we take it that if we let tan half X to be equal to t, what is that going to be? That is going to simply mean that tan x will be 2. So anywhere you see that, right? Okay, I guess I want to color code here to emphasize what I'm about to do. Okay, of course, okay, let me even change. Let me do purple, okay? So it means that this tan x is going to be tan x, and that is equal to 2 times, this is tan half x, and this is also tan half x squared. So it's like you have 2 tan half x. Well, this is me just being finicky, all over 1 minus half x, tan half x. Okay, let me do that properly. Tan half x all raised to power 2, right? So this is tan x equals 2 times t all over 1 minus t all squared. And then finally, we can say that, so we can actually say that tan x, tan x is equal to 2t all over 1 minus t squared. So that is when we do that transformation, that tan half x is t. So by just changing tan half x to t, see what we get now. All right. So with this kind of thing, we can actually extend the same idea to sine x and cos x. So let's see how that works. So let's go now to this. How about when you talk about sine x? We know already that sine x is 2 sine half x cos half x. That's, at least we remember that from when we began this whole thing. So 2 sine a over 2 cos a over 2. Now we are dealing with x. So it means sine x is 2 sine half x cos half x. But see what we have to do here. Since we want to use that transformation, that tan half x is equal to t. For us to be able to do that here, see what happens. You remember that this expression doesn't change if you divide it by 1, right? So if you have 2 sine half x cos half x divided by 1, nothing has changed, all right? Because anything divided by 1 remains the same. But then we have a plan. Because we are dealing with trig and we are working towards getting tan half x out. So see what we have to do. We remember that from the law of trig, right? We know that it is correct that sine squared half x plus cos squared half x is equal to 1. Okay? So it means this one can be replaced by that expression. So we have 2 sine half x cos half x divided by sine squared half x cos squared half x. I mean, okay, that is plus, rather, cos squared half x. Okay, so if that is the case, now we can divide each term by cos squared half x, because we need to get tan out. So we have 2 sine half x, the one at the top, 2 sine half x cos half x. That is one unit, so we can divide the whole thing by cos squared half x. That's the only way we are guaranteed of getting tan uh, and constants. So you have sine squared half x all over cos squared half x. then plus cos squared half x all over cos squared half x. So, one cos here cancels one of this. So you have this to be equal to, okay, I guess I want to change the color now. So this is equal to 2 sine half x over cos half x is tan half x all over down here. Sine squared half x over cos squared half x is actually tan squared half x, and cos squared half x plus cos squared half x is actually 1. Okay. So so far this is still sine x giving us this expression. And just like I said, we are doing this because we want to get to that point where we say that tan half x is the same thing as t. So if we do that here, what do we get? It means that sine x is equal to 2t all over t squared plus 1. Of course, uh just for the sake of order, so to speak. So this is 2t over 1 plus t squared. That goes. So it means that in terms of that transformation, where tan half x is t, sine x can actually be expressed as 2t over 1 plus t squared. Now we're going to see a possibility of applying this. So I'll take one example and you'll have a practice question to settle that. But before we do that, let's talk about cos x. Cos x. So if we have cos x, right, we already know that cos x is the same thing as cos squared half x minus sine squared half x. So it's nice this way because we want to get tan out of it, right? So, and this is equal to, of course, cos squared half x minus sine squared half x. To maintain this way, divide by 1. But we already know 1 can be expressed uh the other way. So we have cos squared half x minus sine squared half x divided by cos squared half x plus sine squared half x. Cos squared half x plus sine squared half x is still 1. So now we can divide through each term by cos squared half x. So we have cos squared half x divided by cos squared half x minus sine squared half x all over cos squared half x. And all of this now over cos squared half x over cos squared half x. Then plus sine squared half x over cos squared half x. So that tells us that cos x is exactly the same thing as cos squared half x over cos squared half x. That's 1 minus tan squared half x. And down here, cos squared over half x, cos squared half x over cos squared half x, that's 1 plus tan squared half x. So we come to that point where we say that tan half x, right? Tan half x is equal to t. So once we invoke this transformation, what do we get? Have that cos x is equal to 1 minus t squared all over 1 plus t squared. So that's what cos x is here for that under that transformation. Now, of course, we can revisit everything we have seen. So you see that so remember that tan x is 2t over 1 minus t squared. Sine x is 2t over t squared plus 1. And cos x is 1 minus t squared plus 1 all over 1 plus t squared. So you can do a quick check to see if everything is in order, right? Remember that check. How do we spell check? K ends it, okay? So, you have tan x is actually the same thing as sine x all over cos x. Okay. So, and what is sine x? We remember sine x is 2t over 1 plus t squared. Sine x is 2t all over 1 plus t squared. Everything divided by cos x. Cos x now is 1 minus t squared. 1 minus t squared all over 1 plus t squared. Okay. So we can multiply through by the LCM, right? So we have 2t all over 1 plus t squared multiplied by 1 plus t squared up here, you know. Then all of that, you have 1 minus t squared all over 1 plus t squared times 1 plus t squared. So this cancels out, this cancels out. And then we end up getting 2t over 1 minus t squared, which is actually correct, right? Which is the tan x we started out with. So you see tan x is 2t over 1 minus t squared. So even under the transformation, everything is in order. So you have tan x to be this. Okay. So let's take a question. Let's take a question or more like an example, right? Let's take an example. Then you'll have a practice question, and that'll be all for this. Okay, so this is the question we want to deal with. So calculate tan half theta, if tan theta is equal to 24 over 7 and theta is acute and theta is acute. So we need to do this. All right. So how do we go? Solution. So we are looking for tan half theta, right? If tan theta is 24 over 7. So it means that you need to be able to express tan theta in terms of tan half theta, like we've already seen. So we know already that tan theta is the same thing as 2 tan half theta all over 1 minus tan squared half theta. Okay. Now, if that is the case, no, you are looking for tan half theta, but then you have tan theta to be 24 over 7. So you could actually, okay, of course, we can do the transformation, right? So if we say, let tan tan half theta be equal to, it doesn't have to be t, it can be anything. Let's say, let's call it q this time around. So if it is q, that means that tan theta itself is actually 2q all over 1 minus q squared. So actually, so what we are looking for is tan half theta. So it means once we find q, we have found tan half theta. Okay. So, and then we know that tan theta tan theta is 24 over 7. So we can actually put that. So we have 24 over 7 equals 2q all over 1 minus q squared. And then we have an equation to deal with. So here we have cross multiplying. We have 7 times 2q equals 24 times 1 minus q squared. So that you have 14q equals 24 minus 24q squared. Okay. So we have a quadratic equation to battle with, and we are solving for q, which is actually what we are looking for, right? So we can rearrange all this, and we have 24q squared plus 14q minus 24 equals 0. So, of course, we can think of the various approaches we can employ to deal with this. But of course, one thing we can do is we can simplify this expression to make things easier. If you divide through by 2, you can have it simpler. Divide through by 2. Okay, let me change the color. If you divide through by 2, you have 12q squared plus 7q minus 12 equals 0. So this makes things a bit easier. And to deal with this, right, we are looking for two numbers, right? So you're looking for two numbers. When you add those two numbers, you get 7, which is in the center. But when you multiply those two numbers, you get 12 times minus 12. That's minus 144. And those two numbers should be factors of 144. So one simple thing I like to do is so once two numbers, when you add them together, you get 7. But when you multiply, you get minus 144. So you can break down 144, right? So you have 2 in 144, that's 72. 2 here is 36. So 2 here is 18. And then what else do we have? We have 2 here, that's 9. So you see 2 times 2 times 2 times 2, that's 16 and 9. Okay, 16 plus 9 is 25, but 16 minus 9 is 7. So that's like, it means we're looking for So it means those factors would be, of course, since 7 is positive, right? So it means we have 16 and then we have minus 9. Minus 9, that's looking like Q. 16 and minus 9. Okay, so those are just ways of arriving at this. So what we just do is to say this is 12Q squared 12Q squared plus 16Q minus 9Q minus 12 equals 0. Because 16 minus 9 is 7, but 16 times minus 9 is minus 144. That's 12 times minus 12. So then we try to factorize. So if we take them in pairs, we have 12Q squared plus 16Q minus 9Q plus 12 equals 0. So what's common to this? That should be, I think, 4Q into 3Q plus 4, I believe. Yep. Then minus 3 is common here, I think. So 3 into 3Q plus 4 again. So, and all of that is equal to 0. So you can have 3Q plus 4 into 4Q minus 3 equals 0. So that means we have 3Q plus 4 equals 0, or 4Q minus 3 equals 0. So you have 3Q equals 4. Sorry, 3Q equals minus 4, or 4Q equals 3. So that means Q equals minus 4 over 3 when you divide through by 3, or Q is 3 over 4, right? But we're told that uh, okay, I mean, maybe that's not a problem. So we have finally got our results, right? So it means that therefore tan theta, tan half theta rather, which we are looking for, tan half theta is either minus 4 over 3, is either minus 4 over 3, or 3 over 4. However, when you talk about minus 4 over 3, right? Should we worry about this? Because we know that theta is acute. I think that should count for something. So for this to be negative, right? For this to be okay, we can say since theta is acute, so tan is negative. Of course, if we revisit the 4 quadrants, right? All positive, only sine is positive, then only tan is positive and only cosine. So this is where our focus should be. So since we want theta to just be acute, then it means that this should be confined to either the first and second, the first quadrant, yeah, because negativity is out of it. So we can conclude that therefore tan half theta is equal to 3 over 4, because tan is only positive in the first quadrant, like that. Okay. Yes, I'm also looking at the possibility of it being here too. For instance, if we have 180 tan 90, tan 90, I think, is undefined, right? Yeah. So, I mean, it's safe to settle with this. Okay, so having done that now, let me just drop a question for you to chew on, which I think is going to test your knowledge of this. So, practice question, practice question, practice question. So, uh, given, given that, given that sec theta, of course, sec is 1 over cos, the reciprocal, of course. Given that sec theta minus tan theta is equal to x, right? Show that, show that, show that t equals 1 minus x over 1 plus x, where t is equal to tan theta over 2. Of course, that's still tan half theta, right? Where t is tan theta over 2. So try this out and see how you can go about it. Thank you so much for listening. I'll stop here for now. We'll continue later. In the next video, I'll be talking about trigonometric equations, which is probably the last part of trig for now. Okay. So if you have not subscribed, be sure to do that. Very importantly, hit the notification bell so that you can always get alerted when a new video is released. Be sure to always comment, be sure to like and share because a lot of people would need help with these things. See you in the next video where I'll be talking about trigonometric equations. Thank you for always stopping by. Bye.